wondering how your LED light bulb that light you up right now produce light? Or maybe not. That's actually not magic. It's just diode. But what is diode then?
Let's begin with the concept of p-n junction. No, semiconductor first. Semiconductor is a material that can act as a conductor or insulator. They have 4 electrons in a valence orbit. The unique thing of them are they have small energy difference between conduction band and valence band. Not overlap as conduction have or too large as insulator. Therefore, electron in semiconductor can be freed by small amount of energy. This characteristic makes semiconductor have great role in electronic device. p-n junction made from 2 kinds of semiconductor, p-type and n-type. p-type semiconductor made by giving 3 valence impurities to pure or intrinsic semiconductor called doping, make it have more holes than electrons. So the majority carrier of this p-type is hole, while n-type semiconductor made by giving pentavalent to intrinsic semiconductor make it have more electrons. Thus, in this type, electron act as majority carrier. When these 2 kinds of semiconductor is joined together, p-n junction will form. To get equilibrium state, 2 kinds of majority carriers diffuse across the junction and they recombine, produce ion. This process makes the n region lose free electrons and make a layer full of positive immobile ion near the junction. As the free electron recombine with a hole in p region, a layer full of negative immobile ion is also created near the junction. As Coulomb law stated, if there is positive charge and negative charge near each other, there will be a force act on these charges. This force will make an electric field that will gradually block electrons in n-type to flow across the junction. This area is called the depletion region. This region will then expand until the total negative charge in this region repels any further electron diffusion to p region. To allow an electron passing this barrier, we need external voltage, which is larger than barrier voltage. For silicon-based p-n junction, has approximately 0.7 volt of barrier voltage, and germanium-based has approximately 0.3 volt. The effort of applying external voltage to p-n junction is called biasing. There are 2 methods of biasing, forward and reverse. Under forward bias condition, n-type is connected to negative terminal and p-type is connected to positive terminal. No terminal or positive terminal will supply holes to p-n junction, and cathode terminal or negative terminal will supply free electron to p-n junction. This free electron will get attracted to hole in a no terminal, so the current will flow. Under reverse bias condition, no terminal is connected to n-type, make the free electron in n-type get attracted to it. Same thing happens on p-type region, which attracted to cathode, and holes will get attracted to cathode terminal. This condition makes the depletion region get wider and wider, and the current will move. But actually, there's likely amount of current will flow in this region, called leakage current. For easier understanding, depletion region acts similarly to resistor, which over large resistance under reverse bias condition. This is the symbol of diode. This is captured or negative terminal, and this is anode or positive terminal. Diode is made from p-n junction arrayed by resin and added a mark at cathode. There's a lot of kind of diode, but in this time we're gonna learn some of them: rectifier diode, Zener diode, and LED. Rectifier diode. This diode is the basic concept of diode, only allow current from anode to cathode. This IV characteristic of the diode shows that to get large forward current, we should apply voltage more than threshold voltage. If you see the condition under reverse bias, there's likely amount of current called leakage current present until the voltage applied is hit the breakdown voltage and conduct a very large current. This very large current can damage the diode itself. For designing the diode, silicon is more prevalent over germanium because silicon diode works better at high temperature than the germanium diode. Other than that, silicon is abundant in earth, make it easy to be found, and make it cheaper than germanium. This rectifier diode is usually used to convert AC current into DC current. It can be half rectifier or full rectifier. To overcome ripples which may come out in the output, we can use capacitor. Zener diode. Zener diode is diode which is specially designed to be operated in Zener breakdown voltage under reverse bias. This diode is heavily doped to get narrow depletion region to get strong electric field inside. When reverse bias voltage is applied to a Zener diode, it allows only a small amount of leakage current until the voltage is less than Zener voltage. When the voltage reaches the Zener breakdown voltage, the current increases rapidly. But why? When the voltage is hit the Zener breakdown voltage, the electric field in the depletion region is strong enough to pull electrons from their valence band in depletion region. The valence electron then become free electron. These free electrons carry electric current from one place to another place. The Zener breakdown voltage depends on the amount of doping. Heavily doped diodes create low Zener breakdown voltage. On the other hand, lightly doped diodes create high Zener breakdown voltage. Zener diode is usually used as a voltage regulator due to its ability to maintain voltage under reverse bias condition with large current changes between the breakdown current IZ min and its maximum current rating IZ max. A Zener diode will continue to regulate its voltage until the current falls below the minimum IZ min under reverse bias. Even Zener diode is designed to operate under reverse bias. If you connect it to super high current above its thermal limit, diode can be damaged too. LED. Actually, light-emitting diodes, or we usually say LEDs, operate like basic diodes. LED only operate in forward bias and can be damaged in reverse bias. But what makes a difference between rectifier diodes and LED? Normal diodes, or we can say silicon or germanium-based diodes, produce heat when electron and hole recombine. But LED is fabricated with semiconductor that can emit light when the recombination happens. The light can be invisible light, like infrared, or visible light. The emitting light depends on how much energy released by recombination. When free electron jumps from conduction band to valence band, because the emitting light happens by recombination, this process should be happen in the depletion region. In LEDs, the energy gap between conduction band and valence band is very large, so the free electrons in LED have greater energy than the free electron in silicon diodes. Thus, the photon released has high energy, which emits high frequency light that can be visible to human eye, or lower to be infrared, even higher to be ultraviolet. The efficiency to emit this light is increased by increase in current and decrease in temperature. The material used for constructing LED determines its color. In other words, the wavelength or color of the emitted light depends on the forbidden gaps or energy gaps of the material, such as gallium arsenide LED emits red and infrared light. Gallium nitride LED emits bright blue light. Gallium phosphide LED emits red, yellow, and green light. Aluminum gallium nitride emits ultraviolet light, and aluminum gallium phosphide LED emits green light.